Okay, guys. So this is a recording from section 17.1, compound inequalities. So we're going to talk about solving compound inequalities. In section 10.8, we solved a couple of them, but here we're going more deeply. So entire section, it's about compound inequalities. So compound inequalities, we already know that's the inequality which have two inequality symbols, sometimes three, but you guys going to see only two in this class. So let me give you the definition. Let's start with definition of A union B. Okay, so the union of sets A and B denote A union B, U stands for union, is the set of all elements that belong to set A or, it's very important because that word or it's important, set A or to set B or to both sets A and B. So let me show you union. What union means? Union technically means that you're adding two sets, elements of two sets together. So union technically stands for addition. So let's draw two sets. We have set A with many elements and we have set B with many elements. So set A, let's do it in red. So that's set A. Set B will be in green. Okay, so union of A plus B A and B sets are going to be all the elements. So all the elements from set A and all the elements from set B. Okay, so in yellow, this is our union. We adding elements from set A and we adding elements from set B. So this is union. Okay, everything in yellow. So union A, union B. Okay, that's union. Now, next we're going to talk about intersection. So next definition, it's going to be about intersection. The intersection of two sets, A and B, denote and this is how we write the intersection. A intersect with B, so upside down U stands for intersection, is the set of elements common to both A and B. So, and it's important because word "and" stands for intersection, word "or" stands for union. So again, let's do the same thing. Let's show two sets. So this is set A, and elements of set A are going to mark in red. And I have set B. Elements of set B are going to mark it in green. And the intersection will be right here. That's the elements which belongs to set A and set B. Okay, so that's the common elements. So right here we have intersection. Right here. Okay, so this is A intersect with B. Okay, so that's intersection. Intersection of A and B. Okay. So unions all elements together, you adding intersection is just common part. Okay. Let's do the first example. Example 1. Finding the union and intersection of sets. So just we want to practice, make sure that we understand. So this is what is given. Given set A, and in the parenthesis we're listing elements of set A R, S, T, U, U, V, W, we have set B, S, V, W, Y, Z, and we have set C, and I'm listing all the elements of set C, X, Y, Z. And I'm going to ask you questions. So first what I'm going to ask you, I want you to find A, B, union C. So again, union, I'm asking you to find the union. So what we're going to do here, union stands for addition, note. So we're going to add all the elements together from sets B and C. Okay, so this is how you're writing down B union C equal. And I'm going to list all the elements which belongs to set B and all the elements which belongs to set C together. If they are repeating, you're not listing them twice. So first what I'm going to do, I'm going to copy all the elements from set B. Okay, so this is set B. Okay, now I'm going to copy all the elements from set C because I'm adding them. Oops, sorry guys. So I'm not going to copy because I won't be able to remove. So all the elements from set C, which is X, Y, Z. So union, you're just adding them together. Now look what happened. We don't want to have repeats. So I have S, V, W, Y. Then I have Z, X. I already have Y. So I'm going to remove this Y because we don't copy them twice. And I already put Z from previous set, so you're not going to list that Z. Okay, so this is our union. We're just adding the elements together. For B, we're going to practice intersection. So we have set A has to be intersect with set B. So intersection, right? Intersection, that's the common elements. That's the elements which repeats, which you're going to see in set A and set B. Okay, so set A, okay, if we want to see it, we have set A has RSTUVW, set B has SVWYZ. So I'm going to check what are the common letters which are in set A and set B. So I see that we have S. I see that both sets has V. And I see that both sets has W. Okay, so, and that's it. So our intersection will be the elements which you guys see in set A and B. So that's the comma elements. So we have S, V, W, because that's the elements which are the same in set A and set B. Okay. Next, I'm going to ask you, let's see if I can remove that. Oops. B had SVW, that was W over there. Okay. C, in example C, I'm going to ask you to find the intersection A intersect with C. Okay, so again, intersection. So we're going to check if there are any elements which repeats, which are the same for set A and set C. So set A and set C. Since set C is smaller, so let me check. Set C has X. Let me see if I have X in set A. No. Set C has Y. Let's see if I have Y in set A. No. Set C has Z. Let's see if set A has Z. No. So look what happened. Set A and C don't have common elements. Okay, so what that happened, that means the intersection is going to be the empty set. So this is the notation of empty set. Empty set that there is no intersection. Also, our textbook for intersection, another notation of empty set, sometimes they're just putting like parentheses and no elements inside. But Alex used like a zero in the line. So that's the empty set. Okay, so that was intersection and union. So there's empty set there. That's a different notation also. So you have two notations of empty set. Okay, let's do example 2. So hopefully you guys feel comfortable with union and intersection. So now we're going to talk about finding the union and intersection of sets. So this is a little different problem because now we're going to talk about inequalities. So given sets A, maybe let's just mark them in different colors. Sets A, and I'm using set builder notation, has all the elements X such that X is greater or equal -1. Given set B has all the elements X such that X is less than 4. And what is given? It's given also set C has all the elements X such that X is greater or equal 9. So we have 3 different sets. We're using set builder notation. And what we need to do, we need to determine the union or intersection and express the answer in interval notation. Interval notation, again, that's when you use the parentheses or brackets. Brackets only when you have inequality and equal sign. Okay, so we're going to do a couple examples. Example A. What we need to do, we need to find intersection. A intersect with B. Again, this is intersection. So first what we're going to do, we're going to graph A. We're going to graph set A. So set A, I use the green colors. I'm going to use two colors, all the three different colors so we can see it. I'm going to graph set A. So set A, that all the x is greater or equal -1. So I'm putting -1, greater or equal. Okay, so we're shading everything, and I will just use this type of shading so you can see a little better. So I'm shading everything to the right. Okay, that's I graph set A. Next, what we're going to do, second, we're going to graph set B on the same number line. So set B, I'm going to put it in green. So set B that all the x's less than 4. So this is 4 less than, so we're not including 4, and I'm going to the left side, right? So I'm shading everything to the left, and I'm just going to shade it that way so you guys can see a little better. Okay, and now what we're going to do, the third step will be, don't forget that we're looking for intersection. So intersection, and you have to read the intersection, and you need to write the answer using the interval notation. Intersection of A intersect with B is the part where two colors overlap. Where two inequalities overlap. So, like you guys see, we see two colors, two inequalities overlap right here in that segment. Okay, so that's going to be our intersection. So the answer will be A intersect with B. Don't forget that we need to use the interval notation. So we have -1 in a bracket because we're including -1 up to 4, and 4 you see open circle, that's why it's going to be in parentheses. So again, this part represents the intersection right here. A intersect with B. That's where two colors, two inequalities overlap. Let's do B. So the same example, but B. Now we're going to talk about union. B union with C. So again, I'm asking for union, which means we're adding elements together. So step 1, so let me just separate them. So first, I'm going to graph B. Graph inequality B and C, just B and C on the same number line. Okay, so B it's in orange. So B it's orange, C it's red. Okay, so let's graph B first. Okay, so B, going back to B, that's all the solutions, all the elements which are less than 4. So I'm putting 4, less than, I will just shade it that way. Okay, less than 4. Okay, so that's B. C, all the elements greater or equal to 9. So we have 9, greater or equal, so I'm including 9, and I'm shading everything to the right. Okay, and now what I'm asking you to find the union. Find B union C. So don't forget that union means we adding elements together. So union, it's not intersection. Yes, I know that we don't have intersection. However, union will be all the elements from set B, which we're going to write down as from negative infinity to 4, plus, which we're using union, all the elements from set C, which is 9 to positive infinity. So unions, we adding 2 elements together. So all the elements from set B plus, which union stands for plus, all the elements from set C. So this is our union. Okay, so that's union. Okay, let's do example C. If I will ask you here, if we have, I would just add it. So this is extra. Okay, so note here to example B. If I will ask you what is intersection, B intersect with C, like you see, we don't have any common elements. So in this case will be empty set. Okay, so intersection is the empty set in this example. Okay. Okay, let's do more. Example 3. So hopefully by now we feel pretty comfortable about union and intersection and the difference between both of them. Finding the union, in example 3, this is what we're going to do. Finding the union and intersection of 2 intervals. Okay, so a little different type of problem because now what I'm going to do, not really so much, I'm going to give you the sets using interval notation. So find the union and intersection or intersection as indicated. Write the answer in interval notation. Okay, so A, this is what we have. We have interval from negative infinity to negative 5, bracket, U, which stands for union, interval from negative 7 to 0. So here again, they're not saying this is set A, this is set B, but you guys can see that we're adding elements together. So I'm asking for union, okay? I'm asking for union. So what we're going to do, we're going to do the same thing. I'm going to graph two intervals on one number line. Okay, so just to see better, again, this one will be in green. This one will be in orange. Okay, so let's graph them together. Number line. So I'm graphing interval from negative infinity to negative 5. So negative 5, we're including negative 5 because you have a bracket. So this is the first interval. And then the second interval is in orange from negative 7. So negative 7, we have parentheses, so open circle, up to 0. Also open circle. Okay, so this is second interval. So we have to find union. Don't forget that the union means add all elements together. So this is what we have. I'm adding all the elements together. So union, it's not the part where two colors overlap. Union, we adding the elements together. So union will be, look what happened. This part is the first interval, and then I'm continuous. So technically union, it's everything what you guys shaded. Okay, so the number line, which is shaded, it does not apply that it has to be intersection of two color. Everything what was shaded. So this is union. Okay, we add all the elements together, and you need to write the final answer using interval notation. So union will be from negative infinity up to 0. Okay, and we're going to keep 0 in parentheses because we have that open circle on 0, so we're not including 0. So union is the entire number line which we shade. Okay, the part of number line which we shaded. Okay, it's not overlapping. It's just the part of the number line which we shaded. Okay, so let's practice more. Now what I want you to do, I want you to find the intersection in example B. So we're going to find the intersection of set of those two sets. So let's find the intersection from negative infinity to negative 5. That was first interval. And we're looking for intersection. And the second interval is the same from negative 7 to 0. I'm going to do the same thing. I'm going to graph it again. So we will only focus on intersection. Don't forget that intersection is the overlap of part of the number line. And of course, I'm using very simple language when you shade it, okay? So let's put those two inequalities, those two intervals together, number line. So we have negative 5, bracket from negative infinity to negative 5. So we're shading everything here, including negative 5. And then I have negative 7, open parenthesis, up to 0, open parenthesis. And I'm shading everything here. Okay. So union, let's use blue. Union, intersection, it's the overlap part of the number line. So we see that two colors overlap right here in that segment. Okay, so this is our intersection. So we need to write the answer using, I will just put the answer right here, in that blue, using the interval notation. So intersection we have from -7 to -5. Since -7 has open parenthesis, has open circle and open parenthesis, so you put in parenthesis -7, comma, -5. And -5 has that closed circle, so we're going to keep it bracket. And this is the intersection. Okay. Next one. We're going to focus right now, since we know already what is intersection in union, we're going to focus on solving compound inequalities with word "and". And means intersection, okay? So "and" stands for intersection. Okay, so let me write this down. Note the word "and" in inequalities, but also in probabilities too, means the intersection of the solution set. Okay, so word "and" technically has the same meaning, means intersection. Okay, we know that symbol already, intersection. Okay, so they have the same meaning. So let's do the example. We have x greater or equal to 8 and x is less than equal 16. So what I'm asking you to do, I'm asking you here for intersection. So we need to find intersection of two inequalities. Okay, so the best way to find that intersection is to graph them together on one number line. Okay, so in green, I'm graphing the first one. So x greater equal 8, this is 8. We're including 8 and we're shading everything to the right. Okay, in orange, it's going to be the inequality x less than equal 16, so I'm putting 16. We're including 16 and we're shading everything to the left. Okay, so the intersection, and means intersection, so the solution will be is the intersection, and stands for intersection. That's the part which is overlap. So we have 8 to 16, both in brackets, because we're including them. Okay, so let me write the steps to solve compound inequality with word and. Okay, and remember intersection. So first, solve each inequality. Here I gave you the solution, but we're going to solve each inequality first. Second will be graph the solution of each inequality on the same number line. So graph the solutions, the solution of each inequality on the same number line. And the third step will be the solution set will be the intersection of two inequalities. Okay, intersection means, again, overlap part. Okay, so intersection, overlap part. Okay, so let's do something a little more advanced. Next example, solve compound inequality. And again, we're solving and which is intersection. Okay. So first one, A. We have 5x plus 2 greater or equal -8 and -4x greater than -24. So first what we're going to do, we're going to solve each inequality. So I'm solving the first one. We're going to move 2 to the other side of inequality. So we subtract 2 from both sides. And we have 5x is greater or equal -10. And now I'm just dividing both sides of inequality by 5 because you need to isolate x. And we have x greater or equal to -2. Okay, so that's the solution of the first inequality. Next, what I'm going to do, I'm going to solve the second inequality. We have -4x greater than -24. So here we need to divide both by -4. So we're dividing both sides by -4 and we end up with x. Don't forget that when you divide by negative, you have to reverse inequality. So now we have x less than and 6. So that's the second inequality. And don't forget that we have and. And stands, we're looking for intersection. Okay, so what we're going to do, based on the notes, when you solve two inequalities, you're going to graph both solutions on one number line. So I recommended that maybe you guys want to consider graphing them with different colors. So the first one will be in green, x greater equal -2. So we're including -2 and we're shading all the numbers to the right side. Like you see, inequality greater match with the direction of number line, which you need to shade. In red, I'm going to graph the second inequality, which is x less than 6 less than, so we have strict inequality, that means keep it open circle, and again less than. The direction of inequality tells you which side of the number line you need to shade, so we're shading everything to the left. Okay, so we graphed two inequalities, and now we need to look for intersection. So intersection, it's the part of the graph which overlap. So like you see, two colors overlap right here in that segment. So this is our intersection. Okay, so the solution set. So the solution set is, and write the answer using interval notation. So we have bracket -2, comma 6 parentheses. So we're including -2 because -2 is shaded. However, we're not including 6 because it has an open circle. So this is the intersection of both inequalities. And again, I left the solution using interval notation. Let's do a different example. Let's do B. We have 3.2y minus 2.4 greater than 16.8 and negative 4.1 y greater or equal to 8.2. So we're looking for intersection. Okay, so first what we're going to do, we're going to solve two inequalities. What I'm going to do, again, since I don't like to deal with decimals or fractions, so my lowest common multiple here, since each decimal has only one number after decimal point, it's equal to 10. So I'm going to multiply all by 10, just to remove the decimals. So I have 10 times, you guys, if you want to, you can solve it with decimal notation, but I'm just going to do it that way. 3.2y minus 2.4, it's greater than 10 times 6.8, 16.8. So I distribute 10 to each. So we have 32y minus 24, it's greater than 168. Okay, and we're solving for y, so I'm going to add 24 to both sides. And we're having 32y, it's greater than 168 plus 24, 192. And I'm just dividing each by 32. And we got 6. So y is greater than 6. So that's the solution of the first inequality. Now I'm going to solve the second inequality. So the same thing, I don't want to deal with decimals. And also this is easy to solve, but I want to review. The lowest common multiple for decimals, since both of them has only one number after decimal, will be 10. So I'm going to multiply all by 10, the same thing. 10 times the left side, which is negative 4.1 y of the inequality, it's greater than equal 10 times the right side of the inequality, which is 8.2. And that will give us negative 41y greater equal 82. And now we need to divide both sides by negative 41. And we're getting y, again, we're dividing by negative, so reverse inequality, less than equal, and you have 82 divided by negative 41. That will give you negative 2. So that's the second one. And again, we're looking for intersection. Okay, intersection. So when you solve both inequalities, grab them together and look for overlap part. So the first inequality, I'm going to graph in red, y greater than 6, 6, everything to the right, that's what you're going to shade it. And the second inequality, I will graph in green, you have y less than equal negative 2, less than equal negative 2, so I'm shading everything to the left. And we need to find the intersection. So like you see, there is no part which overlaps, so there is no intersection. So there is no intersection. Here, if you will need to write the solution set, is the empty set. There is no elements which will come up for both of them. Okay. And I think we good. I think I'm going to stop here and I'm going to record the second video because this lesson is also long. And again, the long videos take me much more time to download. So that's the part 1 of lesson 17.1. I would say part 1. So this is part 1. I'm going to record the second lecture in a second. Okay, guys, thank you for watching. And again, it's not the end of the section. I'm going to record the second video.